question 9, we're going to start off using the factor theorem because we're asked to show that this is a factor. So x minus 4 factor of x cubed minus 4x squared minus a half x plus 2. So in this case we're going to do f of 4 because that's what goes in here and gives us 0. And this is 4 cubed minus 4 lots of 4 squared minus a half of 4 plus 2. And we can see from this we get 64 take 64 minus 2, let's put this in, 64 take 64 minus 2 plus 2, which equals 0. We need to do one more step and say that this as f of 4 equals 0, this implies that x minus 4 is factor. This actually is a required step in the exam, is saying that getting 0 for the result of this means that this is a factor. It's not enough just to assume that the person reading it knows what you've done and why. So we've worked out f of 4, we've got it 0, we've concluded that that means it's a factor. For part B, we're asked to express this as a product of one linear and one quadratic factor. So we're asked basically to factorize this. So we're going to take our x cubed minus 4x squared minus a half x plus 2, and we're going to take x minus 4 out as a factor, just like we do with algebraic division. So we need first an x squared, which would give us x cubed minus 4x squared. If we take this away, we get 0 from x cubed, take away x cubed, and we get minus 4x squared minus 4x squared, which is also 0. That's quite nice. Minus a half x plus 2. Now we need to look at this and work out how many lots of x do we need to get minus a half x, and the answer is minus a half. If we have minus a half of this, we have minus a half x, and we get minus a half of 4, which is plus 2. Subtract this off, we get 0 and 0. So here is our factorised bit. It's a little bit weird having a fraction in there, but we had a fraction in our original equation, so it's not too uncommon to end up with a fraction there. So our curve f of x equals x minus 4 x squared minus a half. So that we've done is expressing, express just means to write out, f of x as one linear, that's this one, it has no power, and one quadratic factor, it's got a squared in it. For part C, if you don't spot this word hence here, we're really going to struggle with this. So we're going to use what we've just done to work out the solutions to this. So this is trigonometry. We'll notice cos cubed, there's an x cubed, minus 4 cos squared, there's an x squared, minus a half cos x, plus 2. So we're making a substitution here. Let cos theta equal x. So that's what we're doing here. We're using the previous thing and the fact that cos theta equals x. This implies that we're going to use this factorised version here. So cos theta minus 4 cos squared theta minus a half equals 0. So what we've done here is we've used our factorised version up here and this. So this implies that cos theta equals 4. We know that this has no solutions, this is a contradiction. In maths you can use the sign for contradiction if you want, which is a hash. No solutions. We also have here that cos squared theta equals a half. Now this has got some solutions. So here we have cos theta equals, if we square root a half, we get 1 over root 2. But we could also have cos theta is minus 1 over root 2. What we need to do now is find some solutions to this. So we've got these two, we've got no solutions for this. If I draw myself a very, very quick cos graph, like that, we'll notice we've got solutions for this one and this one. So here is our 1 over root 2 and here is our minus 1 over root 2. Just a quick note on calculators: if you do square root a half on your calculator, it will give it to you like this. All they've done is taken our 1 over root 2 and they've rationalised the denominator. So if you got to this, don't worry about it, it's still exactly the same thing. What we're going to do is we're going to do cos minus 1 of this, so cos minus 1 ants, and this is going to give us an answer of 45 degrees. So the first one is 45 degrees. It's quite helpful here if you've got a different colour to use a different colour. So this distance here is 45. We've got exactly the same distance here, and we know that this middle point here is 180. So we can see here that this point here is 180. This distance here is 45, we got that from the first one. So it's 180, go back 45, minus 45, which is 135. Theta also equals, we've got another 45, this bit, because we're using identical bits of graph. 180 plus 45, which gets us 225. And finally, this last point is our 360. We've got another identical bit of graph here, which is another 45. So here we're going to do 360 minus 45, giving us 315. And here, degrees, degrees, degrees. Our answers 1, 2, 3, 4, which are the 4 answers we expected. There are different ways of finding these other solutions. You could use a cast diagram. I find using the graphs are the most simple way of doing it, but it's entirely up to you to find a method you're comfortable with.